So this chapter is about collecting data. If you've taken AP Psych, this will make a lot of sense to you. You'll see a lot of crossovers about studies and how we sample and collect data. So that might be helpful if you take that class. Okay, so population is a big concept here. We start with, we study an entire group of individuals. So it might be, you know, all the favorite band or the favorite music person for all of St. Mary's students. So one way of collecting data is to ask every St. Mary's student. That would be a census. The United States government does that every certain number of years, I think 10 years, where they ask every person information about themselves. Can be very cost prohibitive, time prohibitive. It's not easy to do. So usually we end up just taking a sample. So it will take a sample of individuals, and maybe hopefully from that we'll be able to kind of deduce, well, we think this might be the favorite music group for all of St. Mary's students. So we have the population, in this case, you know, all of St. Mary's students. We take a smaller sample of that. We measure something, we ask them a question, we get some information, we collect the data. We make an inference about the population. So if, you know, 40% of St. Mary's students like Taylor Swift, then you, of the sample you took, then you might assume or might make an inference that maybe about 40% of St. Mary's students do like Taylor Swift. Okay. We often draw conclusions from our sample. Okay, so one way of doing this is called a sample survey. Collects data from a sample that is chosen to represent. So we just send out a survey, decide what population we want to describe, decide what we want to measure, and decide how to choose a sample from that population. So oftentimes we have to do that if we're, you know, designing a study, which some of the questions will be about. We've got to kind of tell them, well, how do you plan on doing this? What are you trying to measure? You know, are you measuring the height of all students in the United States, all females in the United States, all, you know, what is your population you're coming from? So this is one of the worst ways to collect a sample. It is called a convenience sample. We scoff or look down on this one. We don't like it. Because usually the data is not very representative of the population. So, so a convenience sample, might give some other examples, but you know, if you just poll your friends, who's your favorite musical artist right now? Maybe all your friends have the same taste in music, and so that wouldn't be a very representative sample of the whole population there. So just asking whoever's close by might not be the best way to go. We really like randomness. If you did do that, if you do get a convenience sample, oftentimes it's going to be biased. And I'd like you to write that down in your notes. Bias means it's very likely to either underestimate or overestimate the true value you're trying to measure. So bias causes all kinds of problems, right? It's not just bad luck. Usually it's bad design more than bad luck. Convenience sampling almost always results in bias. Another type that we don't like is voluntary response. And so this is really easy to set up and do. That's the nice part about it, but the results are somewhat unreliable. Like, you know, it's kind of a poll on a website or something. So like I go to ESPN.com almost every day to check scores or things. And sometimes on there's a little poll at the bottom. It might say, who's the GOAT of basketball? Who's the greatest of all time? And it might have LeBron, Michael Jordan, maybe someone else. And you have to kind of make a decision if you want to participate. Well, if you don't feel strongly about who the GOAT is in basketball, like let's say you only follow soccer, well then you're probably not going to answer that poll. It's optional. But the people who feel really strongly, they're like, oh, Michael Jordan is the GOAT, they're going to vote. And so you're only getting those people who really have strong feelings, and it might not be representative of just like the average person kind of like or just kind of the population in general, which some people are going to care, some people are not going to care, some people are kind of in the middle. So you're only getting those really extreme folks who feel so strongly they really are going to vote no matter what. Call in, text, if you ever had a TV show say, hey, call in and make your vote or something, well, that's a voluntary response. And so you're selecting yourself to be part of the survey or whatever it is you're asking. And so that's not usually going to be a representative group. The group that self-selects themselves is not usually good. I will say this is just big picture. I've seen this being used more, and they're trying to find ways to make it better. Like I do feel like internet, like when the election comes along, which is going to be this year, this coming year, they're going to get some data from the internet from this method, and they're trying to make it as reliable as they can, but it's hard because, again, it's biased. A sample chosen by chance rules rules out both favoritism of the sampler and the self-selector. So if you haven't caught on, if you choose who gets to be asked the question, the sampler chooses, that's usually bad. If the person chooses themselves, voluntary response, that's usually bad, right? So would it be a better way to maybe randomize it, right? Let chance be the kind of picker there, because chance will usually do a better job than someone who might have a bias or something. So random sampling is good, right? We want to involve some kind of process to determine which members of the population are included in the sample. So the classic, and this is one we really like, not always possible to do, is called a simple random sample. So we choose, if there's 300 students in the school, we might choose, 30 or so to sample. So we choose a certain sample size, that would be N, and we're going to ask those 30 people we choose, but they have to be selected in a random way. So it's a simple random sample. Well, how do you do that? So it would be nice if you had a list of every student or every person in the population, maybe give them a number or a variable. You're going to randomize that. So you're going to choose a bunch of random numbers. You can use our calculator. We can use a random number table generator to do that. And then we're going to select the individuals based on the random pattern of numbers that we chose. So they're talking about how to do this with a randomized. So there's like a randomized table of numbers. Has different names, table D in this case. But if you read, you have to kind of describe. Usually, it's just literally a whole bunch of numbers strung together. So in this case, you would, consecutive digits. So in this case, like if you wanted to, read left to right, like you'd be very instructive about this. Ignore any groups of digits that wasn't using a label. Maybe, talk about are repeats allowed or not. It might depend on the setting. So we'll talk about what this means, and you'll select them based on that table. So, for example, if you had these folks, you were going to choose using these hotel brands, I think. I'm going to choose 4 of them. And so we're going to use a line of table D. So table D might look like this. It has a whole bunch of random numbers in random orders. They're grouped in clumps of 5, but you're going to look them in groups of 2 consecutive integers, read left to right. So if you start reading this, you go, okay, like think of these as a whole bunch of groups of 2. So you can see that 6, 9, 0, 5, 1, 6. 1, 6 is the third group of 2, even though it spreads through 2 different groups there. It's the third group of 2. You start at the first one. Is 69 one of our numbers? No. So we just kind of cross it out. Is 5 one of our hotels? It is. So we're going to circle that one or star that one. So I've chosen one of the 4 hotels so far using the random table. And so the method, if you're reading left to right, you're looking at every 2 digits. So if you had 09, that would be the number 9, right? If you read it that way, I guess. And I think we're going to ignore repeats. Let's see what happens. So we already have 2. That's pretty good. 48 is not on our list. 17 is on our list. 87 is not. 17 is also on our list. But again, we've already counted 17. We've chosen 3 of the hotels. It's one of the 3. And the last number on the list is 20, and that happens to be an actual hotel because there are 28 different hotels. And so we randomly chose 4 of them to sample, and that's going to be much better than me choosing or the hotel self-selecting. So that's really good. Okay, let's just try a few problems. Make sure you got today's lesson. This will kind of tell you how you're doing. So identify the population and the sample. So in the first one, part A, in assembly line, a factory produces 500 cars a day. Each day, the quality control managers inspect 25 cars. So every day they take a sample, right, and perform an in-depth review of each car. So the population is all the cars produced that day. So I guess it'd be those 500 cars for each day. And the sample would be the 25 cars that are selected to do an in-depth review. Okay, a politician uses a Twitter poll to find out whether his followers agree with a recent bill that was passed, and 432 respond to this bill. So the poll, that would be voluntary response is the name of that type of poll. So who is this person polling? Well, only his Twitter followers, right? So that would be the population. So all of these politicians' Twitter followers are the population, but only the people who respond are the sample. So in this case, 432. This guy must have a lot of Twitter followers. So I'm a little jealous. He's got more than me here because I don't even have that many followers, I don't think. Okay, so that would be the answers. Second question about bias. So AP Stats teacher was curious about the average grade point of students in the school. So he used 32. This is kind of a convenience sample, right? So he's just in the second period, he's like, well, why don't I find out what your GPAs are? And he averages them, and it says it's 3.85. Well, what type of sampling did he use? I guess I gave that away. That would be convenience. He was just in second period, said, why don't I ask these folks? Explain how bias of the sampling method can affect the results. So bias is when it over-predicts or under-predicts because you designed it kind of poorly. And you designed it poorly because you didn't choose people randomly. And so in this case, because you just chose AP Stat students, well, AP Stat students are cream of the crop, right? It's very possible that they would have a higher grade point average than any of the others. So that wouldn't be fair. It would be biased. Last question, you got a list of students there, and you got a random list of numbers there that were generated from a table or a computer or a calculator. And so describe your method here to select 5 students. So, you might say, I would number all of the students, but 1, 2, 3, 4, starting with Allison and, moving down. I would read the numbers left to right in groups of 2 consecutive numbers. In this case, they're already split up for us, so we don't have to say that, I guess. If I have a repeat, I'm going to kind of cross that out. I'm not going to count it the second time. Because you've already chosen that person. You're choosing 5 of those 29. And if we need more numbers, we might have to get them. But if you look at this, there were 5 that would be selected. Let's see if we miss anything. Label the students 1 through 29. Use a random number generator to obtain 5 different integers. 5 or more, you might need more than 5. Choose the students who respond randomly to share good news. Choose students. Corresponds, yeah. So we say which one corresponds. Like the 4th term would be, in this case, Tessa, I believe. And no, reading left to right. So the 4th term would be Dan and John. Okay, so but it makes sense. So you got to specify, what happens there. You can see that they showed their work. I like that they said they skipped number 14 the second time they saw it. So you have to show a little bit of work sometimes and then choose your photo. Great, that's the lesson for today.